All right, so today we're going to look at VSEPR theory, and I'll talk about what that means. So when we draw a Lewis structure, that's the first step towards finding the shape of the molecule. On paper, it's 2 dimensions, and so in real life, obviously, we're in 3 dimensions, so we want to find what the shape is. The shape helps us see how it's going to interact with other molecules, so the properties it's going to have. And especially when we talk about ways in biology and we talk about enzymes, proteins, etc., their shapes determine how they interact with each other. So the shape of a molecule, or at least close to the shape, can be predicted using the valence shell electron pair repulsion model, or VSEPR model. And that depicts electrons in bonds and lone pairs as electron groups that repel one another and stay as far apart as possible. So how we do this? The first thing we do is we draw the Lewis structure for the molecule, and we count the number of electron groups surrounding the central atom. So we just look at the central atom. So you could have a single, double, or triple bonds. Multiple bonds count as one electron group. A lone pair of electrons, or even an unpaired electron, which we haven't done, but they do exist. We predict the arrangement of electron groups around each atom by assuming that the groups are oriented in space as far away from one another as possible. That's where this electron repulsion comes from, right? So what that means is that the repulsion, they're negative charge, which means negative. They're like objects, like repel, opposites attract. So 3, the shapes of larger molecules having more than one central atom are a composite of the shapes. So what that means is you got to look at all the central atoms or all the different atoms and see the different shapes that could happen, and then you could predict shapes. We won't do any of that, but you can use VSEPR to predict larger molecules, even though we're not going to do that. We're going to stay with small molecules. So that's what VSEPR is. So here's what this chart, and this is an important chart. Either screenshot this or write it down. You can see where it came from. I got the link down here in case you want to see. But here's what we're looking at. So atoms bonded to the central atom. So these are the atoms that are bonded to it. Lone pair of electrons. So these are electrons by themselves. And then this tells us the shape. All right. So we draw the Lewis structure. We look at how many atoms are bonded to the central atom, and then how many lone electron pairs there are, and then we use that information to find the shape. Now, when we look at the shape, a linear shape looks like this. The geometry, and this is what it looks like here. So it's a straight line. The bond angle's 180 degrees. Trigonal planar is here, 120 degrees. If it's bent, the only thing that's different is instead of having a bond here, it has lone pair of electrons, which means it's 120 degrees also. And then you have tetrahedral, which is 109.5. You have trigonal pyramidal, where you take this one away and you put a lone pair of electrons. That's also 109.5. Or you take this one and this one away and you get another bent, but with 2 unshared pairs, which is 109.5. So that's what we're going to go back to as we start to make some of these predictions. So it's going to be we're going to go back to here, right, to see those things. So I'm going to present back up here. So we look here, here, and then we look at our Lewis structure. So here's our Lewis structure. We look at our central atom. In our central atom, we have 2 bonds and 2 unshared pairs, okay? So 2 bonds and 2 unshared pairs. So atoms bonded 2, lone electron pairs 2, so I got 2 and 2. It's bent / angular. So what does bent look like? Well, it's bent, but it could be one or the other. But this, since we have in our water, right, we get 2 unshared pairs of electrons, it's going to be this bent. So this is the shape of water, and it has a bond angle of 109.5. So we count 2 bonds, 2 unshared pairs. We look at our chart, 2 bonds, 2 unshared pairs to see the shape. Then we go to the next item to find the bond angle and what it looks like in 3-dimensional space. All right, so here's another example. We got ammonia. We got N in the middle. It has 3 bonds and 1 unshared pairs. So 3 bonds, 1 unshared pair. So let's bounce back. I got 3 bonds and 1 unshared pair. So it's going to take the shape of trigonal pyramidal. And then trigonal pyramidal looks like this. and it has the bond angle of 109.5. And so I can find all that information out. So step 1, draw the Lewis structure. Step 2, look at the central atom and see how many atoms are bonded to it, how many unshared pairs of electrons, and then use that to find the shape. And then you go to the next diagram to see what the shape tells us, what it looks like, and of course the angles that it takes. On the practice, that's all I'm going to ask you to do.